What's up everyone? In this video, I will be showing you how to program a Danfoss variable frequency drive through LCP simulator. Then for these configurations, we will be controlling our variable frequency drive through remote control. So meaning, we will be using external push buttons and external potentiometer. So for the external push buttons, we have start button and also stop button. So for the motor stop starting, so it basically means the ramp up time or the acceleration time is 15 seconds, and also the deceleration time or the ramp down time of 15 seconds. So before anything else, we must choose a motor rating within 1.5 to 7.5 horsepower, because it is the only horsepower that our variable frequency drive, or specifically the Danfoss variable frequency drive, will be accepting. So here I have a sample AC motor nameplate. Okay, here. So I got this from the internet. So this is a AC motor nameplate. So we can see here the specifications of our AC motor. So before programming our variable frequency drive, we must know the specs of our AC motor, because it is important to match the specs of our AC motor to the variable frequency drive. So from here, we see that the horsepower is 7.5. So this is the motor rating we will going to use for this video tutorial, and the voltage of 460. Its RPM is 1175, 60 Hz frequency, service factor of 1.15, and it is a 3-phase AC motor, and so on. So since we already know the specs of our AC motor, now let's go to the circuit diagram for the wiring of our components to the VFD. So here we can see that we have the start push button, the stop push button, normally close, normally open, and our potentiometer. So we will connect the start button to the terminal 18 and the stop button to the terminal 27. Okay, so it is connected to the terminal 12, 24 volts. By the way, this terminal 18 and 27 are digital inputs. So for the potentiometer, the one terminal is connected. This terminal is connected to the terminal 50, 10 volts, and the ground, and it's analog input at terminal 53 for our potentiometer. So we have here the functions and the settings for our switches and inputs. So the terminal 18, or this switch, is served as the latch start for our variable frequency drive to also start our AC motor. We have also the terminal 27 for the stop push button for the stop inverse, and then the analog input at terminal 53 for the high reference or feedback value, so in which our motor is at 1175 RPM. So it is the maximum RPM our motor can turn, or the speed of our motor. So now with this circuit diagram, let's move on to the actual wiring diagram of our components. Okay, so wiring diagram. So here is our wiring diagram from our circuit diagram before this picture. So as we can see, we have here the circuit breaker. So for the purpose of this tutorial, we will use circuit breaker for the protection of our VFD or our Danfoss variable frequency drive. So let me zoom in this. So this terminal is the L1, L2, L3 that is connected to the circuit breaker. So this one connected to here, L2, and here this one connected to the power input in our variable frequency drive, and also our AC motor, so with its template. So here is the template right from before this video. Then we connect it from the terminal in our variable frequency drive, the UVW. So here W, V, and U. So after that, let's move on to our switches. So first, let us connect the potentiometer to our variable frequency drive. So the 55 terminal is for the common terminal, the analog input at 53, and the 10 volts at terminal 50. So that is the wiring connection for our potentiometer. Now let's move on to our push buttons. So this is our normally open start push button that is connected to our digital input 18, and our stop push button that is connected to the terminal 27, and the rest of its connection is connected to the terminal 12, in which the 24 volts. So that's all for the wiring diagram of our circuit for the remote control configuration. So how does this circuit work? So this push button, if you press this, the AC motor will start. Then if you press the stop button, the motor will stop. So the purpose of this potentiometer is, while the motor is running, when you start the button, is to control the speed of our AC motor. So why is it important to have this if we are using the remote control? Because you don't need to go to the variable frequency itself or the local control panel to adjust the speed of the motor. You just have to use the potentiometer. Like, you just adjust the knob, you just throttle the speed of the AC motor, and the variable frequency drive will do its job to adjust the frequency of the motor, the speed of the motor. So these buttons will also serve as the operation start and the operation stop of our variable frequency drive. So it's in latch start and inverse stop. So when you start the push button, it has a 15 seconds ramp up time. So when you press it, there is a 15 seconds delay, or 15 seconds delay, in which the speed of the motor will be exact, or will be at its ideal speed. So if you set it at if the potentiometer, you set it at 900 rpm, so when you press the start button, it goes from 0 10 rpm up to 100 up to 500 rpm within 15 seconds. So that is what we set, right? 15 seconds, that is the condition before. So this is how the circuit works for our remote control configuration. So now let's proceed to our programming. Let's input all the specs of our motor template to our variable frequency drive. Okay, so we have here our LCP simulator. Then I have here the computed specifications for our nameplate. So we have here the motor power at 5.5 kilowatts, or the 7.5 horsepower. We just convert it into 5.5 kilowatts. The motor voltage at 460 volts, motor frequency at 60 hertz, motor current at 11.16 amps. So why 11.16 amps? Because we multiply the 9.7 amperes times its service factor, which is 1.15. So it will going to be 11.16 amps. So the motor nominal speed at 1175, am I right? 1175 RPM, right? Okay, 1175 RPM. The motor high speed limit at 1175 RPM. So we input all of this and also the ramping up time into our simulator. So first, let's go to our simulator. Then these buttons are used to navigate. So navigate in our simulator. So let's go to quick menus, then quick setup. So first, let's set our language. So press OK. So English. You can also have these other languages. So I prefer English. So next, we set the motor power. So 5.5 kilowatts. So motor power, 5.5 kilowatts. So 5.5 kilowatts. So press OK. So for 4 kilowatts, you set it into 5.5 kilowatts. Next, the motor voltage. So it says here 460. So let's change it into 460 from 400. Okay, so value change. Next, the motor frequency at 60 hertz. Then the motor current at 11.16 amps. Very 0.16 amps. Next, the motor nominal speed at 1175 RPM. 1175 RPM. Then the ramp up time at 15 seconds. So motor stop starting at 15 seconds. 15 seconds, ramp up time, ramp down time. 15 seconds. So ramp down time, ramp up time 15 seconds. Motor speed low limit 0 RPM. Motor speed high limit, it must be at 1175. 1175 RPM. Okay. So let's review it. So our language is English. Motor speed unit, motor power at 5.5 kilowatts, motor voltage at 460 volts, motor frequency 60 hertz, current at 11.16 amps, nominal speed 1175 RPM, ramp up time and ramp down time 15 seconds. then the motor speed low limit 0, the high speed limit at 1175 rpm. Okay, we are set. So next, let's go to our status, main menu. So after we set the specifications for our AC motor, we input the specifications of our AC motor to the variable frequency drive. Now let us configure the digital and analog inputs, those switches and potentiometers, so that the variable frequency drive will recognize it and will properly set the running of our AC motor. So let's go to digital input. So okay, digital input. So from main menu, digital input outputs, then digital inputs. So the terminal 18. So where is it? Terminal 18. Terminal 18 for the push button. Where is our circuit? Circuit diagram. Okay. So our 18, let's set it into latch start. Here 18. Okay. From start to latch start, it's change. So next, the 27 to from coast inverse, let's set it into stop inverse here. So that's all. So we already set the digital inputs. Now let's set the analog inputs. So back, digital input, analog inputs. Okay, analog input for the 53, right? 53. So we set the high reference value because we hear the high. I'm sorry, 1. So this will be 1175. 1175 rpm. High reference feedback value. After that, analog input set. So let's go to the references. Where is it? Reference limit. There, the maximum reference at 1175. 1175 rpm. Back reference function. Okay, reference limit, references, analog inputs, digital inputs. So we already set all of it. Okay, now let's set its operation mode. So let's go to the quick menu, main menu. So let's go to the, where is it? Special functions. So since we will be using a remote control configuration, let's make the operation mode into initialization. Okay, so after that you go to status, click status button. Since the variable frequency drive is at off state, let's turn it on. So you just use the auto on since we'll be going to have a remote control configuration. So as you can see, the hertz, the frequency is changing. It is ramping up. So from here, if you have you click the start button, it will automatically run the variable frequency drive and will send frequencies to our AC motor. So depending on what RPM you set it in your speed potentiometer, it will slowly go to that ideal or to that set value of RPM that you set from the um, potentiometer. So if you set it at 500 RPM, the knob, when you start the push button, it will go to the 500 RPM here slowly within 15 seconds. So that is the ramp up time. So that's all for the tutorial for today. I hope you learned for this tutorial. So we will just using the LCP simulator to effectively or somehow demonstrate to you the remote control configuration for the Danfoss variable frequency dial. So that's all. Thank you for listening. Have a good day.